Okay. So I have a block here. I'm going to put in a vertical planar fault and a horizontal interface. So just very similar to our 3D hex 8. But now I want to put in a fault that's just a subset of this horizontal plane, or sorry, vertical plane. Oh, I'm sorry, I need to do the web cuts for those. So there's this looks very much like 3D hex 8 so far. Now I'm going to create a brick. So I want to take that vertical plane and I want to mark out this extent for my sort of real, what I would call the fault. Everything else really isn't part of the fault. I just needed it to be able to chop the volumes. So I created a volume that is, it's 1 kilometer perpendicular, and it's going to go down. It actually goes, it chops out there, and so I need to, and so what I can do is this. Here's my sheet body, which is that vertical interface. I can chop my volume on that vertical interface. And now I have basically inscribed on that interface the geometry that I want. I can put in this line here. Notice how I could have also done a vertical chop through the entire domain on each end and then done another horizontal. But what I've done is now these curves are chopped into this vertical plane. So my mesh will honor these. So I can exactly define the edges of my fault surface. And so now when I do imprint, merge, and then delete the bodies, I end up, if I click on the surface. So this is another trick that Charles didn't get to, is that when I click surface, if it's not the surface I want, I can hit the tab key and it'll select another surface that is basically further into the volume. And so you can see it's flipping around between the 3 vertices that are consistent with where I had the cursor. It's very handy. So now I have the surface there and the surface down here, without having to sort of chop up my volume into many more smaller volumes. So it's very handy to be able to take a object, whether it's a block, and chop a surface, the sheet body, to mark it up so that it has sort of the boundaries that you want. And so then let's see, I think I have, I can do the mesh. So here I'm doing, this is, I'll show you what, so I need to show, I don't have so I just did a hex mesh. In this case, everything can line up right along the boundaries because I picked my geometry. I was going for the simplest geometry here, discretization. But if I did tets, I would have all my nodes lining up along where I inscribed on the fault surface. So it's very handy. I use it a lot in benchmarks when I'm told exactly how big my fault has to be, and so forth. And you'll see my node sets. Here, let me turn off here's my fault node set. It's a little hard to see there. You can see a little better. There's my fault node set. So I could just select those surfaces to get all the nodes on there. And then here's my buried fault edge. So I select the nodes that were along those curves to define my buried edges. Then I also went for the full fault plane, and then the various pieces as well. I did that early on. I did that in the geometry. I did that way up here. I did a web cut with my fault surface and a web cut with my material interface. And it's once I did those web cuts, then I went back and I chopped my sheet body surface. So I wasn't chopping out those volumes, I was chopping out the original surface. It's a little complicated, it's a little sort of trick to be able to mark, allows you to mark, and then doing the imprint, I was able to mark that surface. So it's not exactly something you might think of, but it's, stick in your back pocket as a trick to use. Charles, when am I supposed to end? Do I have 15 minutes? I'm supposed to do an hour and a half? Yeah. Okay. I'll end before. I think I'll be finished before that. So we're going to now, are there any other questions? These are for the debugging session tomorrow morning, and so I'll post a tarball on the wiki, and I'm purposely putting in about 5 errors in a number of different simulations, and we're going to go through and fix them tomorrow. But I needed a mesh, and so I wanted to make it like 3D Hex8, but I wanted to have a fault that was embedded in the middle. So, any other questions? Yes. Can you? Okay, basically you saw how complicated it was for Charles to put a bias factor in a 2D case. So now we're going to look at, the next example is to not have to go through all of these curves specifying bias factors. How can you sort of be smarter about specifying the discretization size so you can have to do a lot less work? For which? For the sizing function one? The Python script that adds the Excel file calls a mat prop efficiency decomp that we build it ourselves. No. Okay. We'll see what. Did you delete it? No, so we're meshing qubit cell size. It could be what likely happened is that it's in the repository, but it got left out of the make file, which bundles things up that go in the binary distribution. So it would not be your fault, because I don't usually check that all of the examples run using the binary. Okay. But I was doing, yeah. So we all, Charles, can you here make note of that? It should be in the add fix. It should be in the branch that we've been using to update the meshing. You could just, I don't know.